In this video we will talk about models. A model in Lunar Moon Engine is a 2D object, and this object can be sized, moved or rotated, and the model can have one or more textures, which are the actual graphics. So we will extend our program. First we will reorganize our code to make it more readable. Then we will add a model with one texture, and after the great tutorial text faded out, which will be implemented by us later, this model can be moved to the left or to the right by clicking the mouse. So let's now reorganize our code to make it more readable. We will implement two functions for that. The first function will load all our resources here, and the second function will do calculations inside the loop. First we will write our loading function, and we will do this by typing in void load, and here we are going to pass our engine variable, and we're going to copy all these loading function calls and paste them. Then let's add our calculation function. We are doing this by typing in void calculate, and again let's pass our engine variable, and let's copy these function calls and let's paste them. Okay. We are now able to call these two stage functions by using a switch statement and let's implement two cases. The first case will be the loading stage, and the second stage will be the calculation stage. What we need now is a stage variable. Let's use this data type and let's call it stage, and we will set this to 1. And again, 1 was the loading stage and 2 is the calculation stage. Now we are able to call our loading function here. This is stage 1, and after the loading function has completed, we can change the stage value to 2. And next time the switch statement is being entered, it will remain in case 2. So here we will call our calculate function, and of course we need to enter stage here. Okay, let's build this one. Okay. As you can see, the code to me is more readable now. Let's call the executable file, and it's still working. Okay. And there is another issue with all these IDs we are using, like 1 for this text or 17 for this font, because it might get a little complicated to remember all these IDs depending on your code size. So what we could do is to use some constants instead of these IDs, and let's do this by starting with the ID for this font. We use define font, and it's 17. Let's use it here and here as well. Okay. Let's now do the same with this time event, and let's call this one fade in, and the value is 42, and use it here and here as well, and this is more readable. And of course we need to do the same with the text. and let's call this one great tutorial because that's the text, and the value is 1. And we need to use it here, 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 and here as well. Okay, and here. So now I think there shouldn't be any problems for you to read this code at some point in the future. We completed our first task now by reorganizing our code. Let's now add the text fade out effect, and let's first add another constant, and let's call this one fade out with a value of 43. Then of course we need to create the time event by using this function again. Pass fade out, and this time event should take place at, let's say, second number 8. And this will work the same way as the fade in effect, with the only difference that we will pass a negative value here. Instead of 40, we will pass minus 40. And for that we need to make sure that the fade out effect will only start after the fade in effect has completed. And we're doing this by typing in and not time event reached fade out. So the whole fading in effect will complete first, and the fade out effect will not start until the fade in effect has completed, because this time event will take place at second number 8. So let's type in else. So if this time event has been reached, we can fade the text out. We can copy this and add a minus. So let me summarize it again. If the fade in time event has been reached, but not the fade out time event, the text will fade in. Else, if the fade in time event has been reached and if the fade out time event has been reached, this code will be executed, and this is our fade out effect. So I hope this was clear. Let's now build the application again, and let's execute the executable file. That's the fade in effect, and that's the fade out effect. Great, it works. Now that we've completed our second task, we can now finally add our model. And let me show you my model first. His name is Bob, and here you can create your own model, of course, but it should be a JPEG or a PNG file. And Bob can be found in this location again. This is the folder where your executable file can be found, and I put him into the media folder as well. So let's now create Bob, but before we can do that, we need to define Bob, and let's give him a value of 1. And now we can call this function here model create Bob. To see the actual graphic, we need to call model create texture. So only a texture will be visible. So the first parameter will be Bob, and the second one will be a unique ID, and this ID must be unique to this specific model, and I chose 1, and this is the location now where the graphic file can be found. And you know what? Let's center Bob as well. And we are doing this the same way as we did with the text. So let's copy these two lines and let's paste them. And the model class has the same functions as the text class. So there's a model get size function and a model set position function. So let's change this to model. And of course we need to use Bob instead of Great Tutorial. And due to the fact that we want to display images now, we need to initialize the image library. So let's call init image. Let's build the application now. Let's execute the application. And here you can see Bob. And wouldn't it be great if we would only display Bob after the text fading out effect has completed? Well, let's do this by making Bob invisible first by calling the model set visible function. Well, first we need to pass Bob and then let's pass false. So this function will make a model invisible. Now we need to add the logic that Bob will become visible after the text has faded out. And we can do this by saying if the time event has been reached, well, the fade out time event, and the alpha channel value of this text is 0 again, then the text has completely faded out. So let's type in this one, and to receive the alpha channel value we call text get alpha. Let's pass the ID equals 0. And then we can make Bob visible. Let's pass Bob, and this time we pass true. So let's build the application again. And let's try it. Well, Bob is invisible now. And now the text is fading out. And now Bob is visible. It worked. And you know what? Let's not change the background color. Let's keep it blue. Last thing we want to do now is to move the model, and the logic will be that if the mouse cursor is on the right side of the model will move to the right, and the other way around, if the mouse cursor is on the left side of the model will move to the left. And for that we are going to create a function, and let's call this one move Bob, and let's pass our engine variable. And let's only move Bob after Bob is visible. So let's call the function here move Bob, and let's pass engine. Now, to implement our model movement function, we first need to receive the cursor position. And the cursor position will be a point on the screen, so it does have an X and Y coordinate. Let's do this by creating a variable of type stl point. Let's call this one cursor position, and let's now call mouse get position. This function will return the mouse cursor position. Now of course we need the current model position as well, and it's the same procedure. Let's call this one model position, and let's call the model get position function, and let's pass Bob. Let's first check if the mouse button is being pressed, and we are doing this by typing if mouse event, and the first parameter will check if the mouse button is being clicked or released. So we're checking if the mouse button is down or being clicked, and the second parameter will be the actual button. In this case it's the left button. So inside the statement we can calculate the movement of the model. Let's start with left, and we're checking if the cursor position point X is less than the model position point X. Well, in this case the cursor is on the left side of the model, and this is because the Lunar Moon engine coordinate system starts with 0, 0 at the left upper corner. And inside the statement we can move the model to the left, and the other case will be the movement to the right. And here we're checking if the cursor position point X is greater than the model position point X. In this case the cursor position is on the right side of the model. So let's now create two directions for our model bob, and let's define them first. First one is left and the second one is right. Then we can call the model at direction function, and this function will create a direction for a model. So the model will be able to move into this direction then. So let's pass Bob again, and then let's start with the left direction, and again this ID must be unique to directions for a specific model, and the last parameter will be a vector, a 2D vector, and since we want to move the model to the left we type in minus and let's say 100, and this is a floating point number, so the model will move to the left by 100 pixels per second, and this one is 0 because we do not want to move the model up or down. And of course we need to do the same with the other direction, so let's copy this line and let's change this one to right, and let's delete the minus. So the speed will be equal in both cases. So now we should be able to move our model. So let's enter this function again and let's move the model to the left here by typing in model move direction. Let's pass Bob and left, and we need to do the same with the other direction, and let's change this one to right. Okay, so let's test our application again. Let's build it first, and let's call it. Well, first the text is fading in. Now it's fading out. And there's Bob. So let's try to move Bob. And as you can see, it works. Yeah, it works. So we do not have a case if the cursor position equals the model position. Well, you can implement that if you want, but that's my quick introduction to the Lynar Moon Engine model class. So thanks for watching.